Kia ora Year 12. In this video, I'm going to start going through the school exam for Stats 2. This is from the 2011 June paper, paper number 72. But I think, as usual, the marking schedule is not really that much use. So I'm going to put my work solutions up, but also going to go through each question because it's pretty clear that some of you have done more revision for Pure than you have for Stats. So there's some really easy mistakes that were made in question 1. Question 1 is one where we've got the weight of bags of fuel with a mean of 3.2 kilograms and a standard deviation of 0.04 kilograms. So even before you read that question, you kind of know that it's probably going to be one of these ones where we have to find the mean and the standard deviation. And sure enough, it is, right? The total weight of a random sample of 3 bags is denoted by T kilograms. So we've got bag 1, X1, bag 2, and bag 3. We don't have a linear combination. We have the sum of 3 things with variation, right? So T is not equal to 3x. And if you say that it is, you're very likely to then make this mistake, which is to say that the variance of T is 3 squared var x. It's not, right? It's just the sum of the variances of the 3 bags. So if we take a little bit of time and write T equals x1 plus x2 plus x3, then the rest follows pretty easily, right? E of T is equal to E of this, and E of this. So that's equal to 3 times 3.2, which is 9.6. And the variance of T is equal to the variance of bag 1 plus the variance of bag 2, and so on, which equals 3 times 0.04. Remember, sorry, times 0.04 squared. So we don't ever work at the level of the standard deviation when we're working with our expectations algebra stuff. We work at the level of the variance. Okay, so we got given the standard deviation. It's really easy from there to find the variance. So the variance of T works out to be 0.0048. And then it's a simple step to get the standard deviation, which is the square root of that, giving us 0.0693. So I saw a range of expected mistakes in this question. The biggest one was doing the thing where you tried to say it was a linear combination. And the second thing was people who tried to do 3 times the standard deviation in here. So that got you into trouble as well. The second question is one where we have to be confident with the material in chapter 13 of the textbook. Now, there are 2 ways to do this question, and I'm going to go through both of them. The first way is kind of directly doing what we're asked to do. So we've got x as a random variable, and it's got a binomial distribution. So far, so good. And then we're told that we've got a random sample of 60 values of x that's being taken. So what we're doing there is we're doing 60 goes of, for example, throwing a 4-sided die 12 times, right? And we have to find the probability that the average number, the sample mean on those 60, is less than 2.8. So we're working on a probability that x bar is less than 2.8. And that means we need to know something about, or quite a lot, about the distribution of x bar. We've got 60 values, so even though x is binomial with these parameters, we know by the central limit theorem that the sample mean is roughly going to be normally distributed, and it's going to have a mean and it's going to have a variance. Right, so the expected value of x bar will equal NP, right, which is equal to 1/4 times 12, which is 3. So on average, we'd be expecting to get 3 successes in each group of 12. What about the variance? Well, we know that the variance of 1 go is NPQ. So the variance of x is equal to NPQ, which is 12 times 1/4 times 3/4, which is, what do we get? 2.25 or 9/4. Either of those is fine. And the variance of the sample mean is going to equal 1/n times var x, right? So that's going to be here. The n in here is the 60, right? So it's going to be 2.25 over 60. And now we're basically ready to go back up and work out this probability, because we've got the average, we've got mu, and we've got the variance. So the probability that x bar is less than 2.8 is equal to the probability that z, the standard normal, is less than 2.8 minus 3 divided by this, the standard deviation of the sample mean, right? So what we've got here is the standard deviation of the sample mean is equal to that, the square root of the variance of the sample mean. Okay, so figuring all of that out, now we're on to the easy bit. We've got the probability that z is less than negative 1.033. So we're looking for this area here, which is the same as this area up here. So it's 1 minus phi of 1.033. And when you hop over to your table, which is magically here, there's 1.033. What have we got? 0.8492. Which gives us 0.1508, but to three significant figures, that's 0.151. So that's that question done. But I'm going to do this a different way, so don't hang up the video just yet. I know some of you probably are going, oh, we really don't like this sample mean distribution stuff. So the other way that you can think about this, and it comes out, of course, to exactly the same Z value, is to think about, well, if we don't want to work with the sample mean, we could work with the total number, right? So if you think about, you've got a random sample of 60 goes of these, and you've got this on average, we could try and figure out the distribution of the total number of successes, right? So we've got NP is equal to 3, and we've got NPQ is equal to 2.25. So T here is your 60 goes. And the expected value of the total is going to be 60 times 3, which is 180. And so instead of working with the probability that the sample mean is less than 2.8, we could work with the probability that the total number of heads or tails or whatever it is less than 168. Okay, so before we had the probability that x bar is less than 2.8, that translates to having a total number of successes of 168. So let's play around with that and see if it works out to be the same. So we've got E of t is 60 times 3. And what about the variance of t? Well, the variance of t is the variance of each of these added up together. And there are 60 of them, so it's 60 times 2.25. So it's a lot like what we had in question 1. That gives me a variance of 135, and that gives me a standard deviation of the total of 11.61895. So now if we want to figure out directly the probability of the total being 168 or less, fewer, probability that t is less than 168 is equal to the probability that z is less than 168 minus 180 divided by 11.61895. And you can see that, of course, that's going to work out because what you've got is a whole lot of dividing by 60 compared to the first Z value. So if you take this calculation and you go and look at the one we had before when we had x bar, you can see we've just got a whole lot of common factors. So this again works out to be the probability that Z is less than negative 1.0328. Okay, so then we're down to the rest of the calculation exactly the same. I'd like you to be confident with both of those. Sometimes you have to be able to work with the standard deviation, the distribution of a total, but you must be confident working with the distribution of a sample mean. Thanks for watching. Please send me an email if you still don't get these. And a lot of you have got gaps in chapter 13, so well worth spending some time in the next couple of days going over that section of the test book.